Hey everybody! This is part 2 to my Deploy Opnsense at Home video series. If you haven't seen part 1, I will link off to it in the description. We will be picking up right where that video left off. So at this point, you should have an Opnsense firewall installed and running with a new user other than root. You should have DHCP and DNS working on your local network. We're going to look at the following in this video: making firewall rules, making aliases, some common firewall rules that I personally use. So without further ado, let's dive on in. Part 1, making firewall rules. If you don't have a good understanding of how networking works, this part can be confusing. I will try to keep it as clear and concise as possible for what we're going to be doing, and so that hopefully this is as digestible as possible. An advanced understanding of networking will not be needed here, and I will try to provide some tips to help create useful firewall rules without needing to dive too deep. That being said, the more you understand about networking, the easier this will be. So let's review how a firewall works. When two devices talk to each other over a network, they do so by sending packets to each other. These packets contain the data that two devices are trying to exchange. However, these packets also contain additional information, such as the source and destination IP addresses, the port numbers that are being used to communicate, and the protocols being used. Your firewall, when it sits between two devices, such as between your PC and a destination web server, for example, Amazon.com, will read this information in the packet, and you can create firewall rules using this data to allow, block, or drop the traffic. For example, you could create a firewall rule that blocks traffic that comes from your computer and is going to Amazon. This would block Amazon specifically from your computer. Firewall rules will be written to a table, and the rules are applied in the order that they are read from that table from top to bottom. So if you have the first rule in your firewall as an allow all traffic from your PC to anything, then your second rule is to block any traffic from any source to Amazon. Your PC can still get to Amazon because the rule that's higher up on the table will take priority. However, nothing else would be able to. This is because there's no rule allowing PCs other than your computer to access Amazon. It's also worth noting that any parameter not declared in a firewall rule is implied to be any. So we can read the rules that we make as block traffic from any source on any port to any destination on any port using any protocol. In this example here, we can change any of the any values to be specific examples or even ranges of examples to make the firewall rules match. We can also change the action at the start of the rule from block to allow or drop. We can also change the protocol if we're looking to filter out specific application protocols. However, for the most part in these examples, we're just going to use TCP/UDP. Now, something that can be difficult to understand is that your firewall, once it allows the connection to establish, will allow all traffic related to that session to continue. So for example, you don't need to permit every packet from your computer to Amazon, then also allow all traffic back from Amazon. If we allow the outbound connection from your computer to Amazon.com, once that connection is established and allowed through the firewall will know to allow the response from Amazon since the connection is related and established. All that means is that your computer has to initialize the session to the destination. So now if we look at how Opnsense is set up for handling firewall rules, under Firewall, Rules, you will see your LAN interface as well as floating. Floating is helpful if you want to apply your rules to multiple interfaces at one time, rather than making rules under each individual interface. For now, we can just focus on your LAN and WAN interfaces. Opnsense considers anything coming in to an interface to be inbound or ingress traffic. So anything going into the LAN interface or into the WAN interface is inbound traffic. For example, your computer connecting to the firewall is inbound traffic, the same way that Amazon trying to connect to your firewall is inbound. Now the traffic you send to Amazon will go in the LAN, then will go out the WAN. This was one of the things that confused me early on, so I wanted to point it out. The response would then come in the WAN and out the LAN. So let's review how you create firewall rules in Opnsense. Go to the LAN interface and press the plus button. I'm going to walk through some of the common options you may want to know about. I'm not going to cover every single option in here, however. That would just take too much time, and Opnsense has thorough documentation on what each of these does. Action is what you want the rule to do. Block, allow, or reject the traffic. You will primarily use block and allow. Disabling a rule can be helpful for troubleshooting, or if you want a rule that you may turn on or off as needed. A neat example of this is creating rules to block kids from certain websites until the rule is disabled. I've heard of people using this as a way to limit YouTube time for their kids until their homework is complete. Interface is what interface or interfaces, if you're using the floating section, this rule should apply to. And direction is, as I mentioned earlier, inbound or outbound from the perspective of the specific interface you're applying the rules to. TCP/IP version is where you will select if this rule is for IPv4, IPv6, or both. All of my examples are going to just be in IPv4, as the topic of IPv6 is out of the scope of this series, but you could set your rules to use both as mentioned previously. Source invert, and further down, destination invert, are a way to add a not statement to your firewall rules. For example, the way we laid out a firewall rule earlier, let's say we have an example rule like this. Block any traffic on any port to Amazon.com on any port using any protocol. This would block any traffic to Amazon.com. If we invert the destination with that checkbox, the rule would now read, block any traffic on any port to not Amazon.com on any port using any protocol. This would block any traffic that's not going to Amazon.com. And we can do this for either the source or destination, or both. You'll notice here that this is represented by an exclamation point. This is true in Opnsense as well when you create the rules. Source, we can select from existing options, or we can enter an IP address or subnet manually, or use an alias. More on that later. Some common ones to use here are LAN address. This is just the LAN IP address of the firewall on that specific interface. LAN net. This is all IP addresses in the LAN subnet, for example, 192.168.1.0 through .255. If you want to set a single IP address, you can use the single host or network option, and then enter the IP address and set the subnet to 32, which would mean just this IP. The log option here will add this rule to the log file when it matches traffic. This is great for troubleshooting, and I always log my block rules. This will allow me to review the live log and quickly see why something is being blocked. I don't tend to log my allow rules unless I'm troubleshooting why they're not working. You should always give your firewall rules good descriptions, as these descriptions will show up in the logs and will help you identify what rules they are when in use. Build good habits here, it'll save you a bunch of time later. So now, let's see what some firewall rules we may want to set up are. Let's say you have a website you want to block. You could click Create a Rule and block all inbound traffic on the LAN interface from reaching out to that destination specifically. But you'll see that it only accepts IP addresses as the destination. So we could go out and we could do an NS lookup on the website name to get its IP address, but there's a good chance that that website will have multiple IP addresses. So instead of making a rule for each IP address, which, by the way, can change over time, we can use aliases. Aliases are a way that we can create groups of IP addresses, ports, countries, or even URLs that the firewall will be able to interpret. For example, if we go to the aliases section, we can create an alias that has the Amazon.com URL, and now hit save and apply. Now, if we go back to our LAN interface and start making a new firewall rule, we can see in the destination section, if we scroll up, we will find the name of our alias. So now we can create this firewall rule that says to block any traffic to destination Amazon.com. We can also use this to add multiple URLs from the alias section without having to update our firewall rules. This is a great way to block specific websites you don't want your users connecting to, or to limit the access of specific devices. When you're creating and testing block rules in your firewall, it's a good idea to have a test client or a test machine that you set as the source while you test your rules. This way you can make sure that blocking is working, but also that you haven't accidentally broken the access of a whole bunch of clients at once. Then once you've tested the rule is working the way you anticipated, you can change the source to the group that you want the rule applied to. So what are some firewall rules and aliases you might want to create? Here are some that I personally use. Feel free to make use of any of these or tweak them for your needs. The first one is RFC 1918. RFC 1918, or Request for Comment 1918, is a rule from the National Institute for Standards of Technology that defines what a local IP address and an internet IP address, or WAN IP address, are. We create an alias that defines local IPs so that we can create firewall rules that interact with whether something is on the internet or not, rather than what specific website it's on. This will be a network type alias with the following content. DNS servers. This is where I enter the IP address of my approved DNS servers. For example, my firewall, my Pi-hole, and Cloudflare. This allows rules to make sure that your local devices will have DNS and that you can block unwanted DNS servers. This will be a host type alias with the IP address of your DNS servers in the content. Make sure to either add the IP address of your forwarder, such as Cloudflare, or create a separate rule for them. No internet devices. This is a list of devices I don't want to have internet access. This is a host type alias with a list of IP address of those devices I don't want to have internet. Now for the rules. Here are some of the rules that I use with those aliases. Allow internal traffic to the DNS server. I create an allow rule that is floating or on the LAN interface as an inbound rule, and I will allow traffic with a destination of DNS servers on specifically port 53, which is the port that DNS uses. This is paired with a block any internal traffic to a non-approved DNS server. So on the same interface, I create a blocking rule for any port 53 traffic from any RFC 1918 address. So that's source RFC 1918, destination port 53, and that's a block rule. We need to make sure that that rule happens after the allow rule that we just made. Next, I have a block traffic from no internet devices rule. This is just a block rule that blocks from no internet devices to non-RFC 1918, meaning that I have the RFC 1918 alias set as a destination with the destination invert flag checked. These are just a few examples. As you can see, there's a lot more that you can do here, and in the next video, we're going to go through setting up UPnP and NAT, so that if you have any gamers in the household or you like to play Xbox or PlayStation, we can get you that sweet, sweet open NAT for the best multiplayer gaming experience. So stay tuned for that one. Until next time, thanks for watching.